Hey everyone, and welcome back to the channel. If you're fascinated by the incredible pace of artificial intelligence, especially large language models or LLMs, then you're in for a treat today. We've all seen LLMs like GPT produce amazing human-like text. But what happens when they don't have the latest information? Or what if they need to answer questions based on specific private documents they weren't trained on? That's where a revolutionary technique called Retrieval Augmented Generation, or RAG, comes into play. And trust me, if you're in the AI space, this is something you absolutely need to understand. It's not just an incremental update, it's a paradigm shift in how we can make LLMs smarter, more accurate, and incredibly more useful. So what exactly is RAG? Imagine an LLM, a super intelligent student who has read a vast library of books. That's its training data. Now imagine giving this student access to a real-time curated library of the most up-to-date and specific information they can consult before answering any question. That, in essence, is RAG. Retrieval Augmented Generation is an AI framework that enhances the output of large language models by grounding them with information retrieved from external authoritative knowledge sources. Instead of just relying on its pre-trained knowledge, which can be outdated or too general, an LLM using RAG first retrieves relevant information related to your query and then uses that information to generate a more accurate, current, and contextually relevant response. Value proposition, why RAG is a big deal. Host. Now you might be thinking, okay, sounds cool, but why is this better than, say, just fine-tuning an LLM? Great question. Fine-tuning involves retraining parts of an LLM on a specific dataset. While powerful, it can be expensive, time-consuming, and you might need to do it repeatedly as new information comes in. Also, fine-tuning doesn't easily allow the model to cite its sources or easily update its knowledge base with breaking news, for example. RAG offers several key advantages. Up-to-date information. This is huge. LLMs have a knowledge cutoff based on their training data. RAG systems can connect to live databases, real-time news feeds, or updated internal company documents. This means your AI can answer questions about current events or the latest product updates accurately. Reduced hallucinations. Hallucinations are when LLMs confidently make up incorrect information. Because RAG grounds the LLM's response in retrieved factual data, it significantly reduces the chances of these fabrications. The LLM isn't just guessing, it's referencing. Increased transparency and trust. RAG models can often cite their sources. Imagine asking an AI a complex question, and it not only gives you an answer, but also points you to the specific documents or data points it used. This makes the AI's output verifiable and more trustworthy. Cost-effectiveness for dynamic knowledge. Continuously fine-tuning an LLM for rapidly changing information is often impractical. RAG allows you to update the knowledge base the LLM refers to, which is typically much cheaper and faster than retraining the entire model. Domain-specific expertise. Without full retraining, you can point RAG to your company's internal knowledge base, technical manuals, or specific legal documents. The LLM then uses this specialized information to answer queries, acting like an expert in that specific domain without needing to be explicitly retrained on all of it from scratch. How does RAG work? The nitty-gritty. Jose, all right, let's peek under the hood. How does this magic actually happen? It's generally a three-step process: retrieval, augmentation, and generation. Step 1, retrieval host. When you ask a question, your prompt, the RAG system, first uses a component called a retriever. The retriever's job is to search through your specified knowledge base. This could be a collection of documents, a database, websites, etc. It uses techniques like semantic search or vector embeddings to find the chunks of text or data that are most relevant to your query. Think of it like a super fast, super smart librarian finding the exact paragraphs in books that can answer your question. These documents are often pre-processed by chunking them into smaller, manageable pieces and then converting them into embeddings numerical representations that capture their meaning, which are stored in a vector database for efficient searching. Step 2, augmentation host. Once the most relevant information is retrieved, it's augmented to your original prompt. This means the system takes your question and combines it with the context from these retrieved documents. So the LLM doesn't just see your question in isolation, it sees your question plus the relevant information it needs to answer it. Step 3, generation host. Finally, this augmented prompt, your original query enriched with the retrieved context, is fed to the large language model. The LLM then uses its powerful language capabilities to synthesize this information and generate a coherent, contextually accurate, and informative answer. Because it has this extra relevant information, the answer is much more likely to be correct, specific, and helpful. Real-world examples and use cases. This isn't just theory. RAG is already powering some amazing applications. Smarter chatbots and virtual assistants, customer service bots that can access the latest product information, troubleshoot based on current manuals, or provide up-to-date policy details. Example, a customer asking a chatbot about a new product feature, and the bot gives a precise answer referencing the latest update log. Internal knowledge management, employees asking complex questions about company procedures, HR policies, or technical specifications and getting precise answers sourced directly from internal documents. Example, an engineer querying a system. What's the tensile strength of material X according to our latest spec sheet, and getting a direct answer with a link to the sheet. Content creation and research. Writers and researchers using RAG to quickly gather information from vast data sets and generate summaries, reports, or articles grounded in factual, cited data. Personalized education, AI tutors that can pull information from specific textbooks or learning modules to answer student questions. Healthcare information systems, providing clinicians with quick access to relevant medical research or patient history to aid in decision-making while adhering to privacy. Limitations and the future of RAG. Now, RAG is fantastic, but it's not a silver bullet. The quality of the retrieved information is crucial. If the knowledge base is poor, the answers will be too. The retrieval step itself can be complex, and ensuring only truly relevant information is retrieved without missing key details is an ongoing area of research. There's also the challenge of handling very large or diverse knowledge sources efficiently. But the future of RAG is incredibly bright. We're seeing advancements in hybrid search, combining keyword search with semantic search for even better retrieval. Multimodal RAG, retrieving not just text, but also information from images, audio, and video. Self-correcting RAG, systems that can evaluate the quality of retrieved documents and refine the search if needed. More sophisticated agentic RAG, LLMs that can perform multiple retrieval steps, or even ask clarifying questions to improve the information they gather. RAG is fundamentally changing how we interact with and leverage the power of large language models. It's making them more reliable, more factual, and ultimately more useful in the real world. So what are your thoughts on Retrieval Augmented Generation? Can you see it transforming your industry or your projects? I'd love to hear your ideas and questions in the comments below. If you found this video helpful and want to stay ahead in the world of AI, make sure to hit that like button, subscribe for more deep dives into cutting-edge AI topics, and ring that notification bell so you don't miss our next video. We'll be covering more exciting developments, including practical tutorials and expert interviews. Thanks for watching, and I'll see you in the next one.